Start recording. All right, so folks, welcome to week 5, day 1 of golf. We are going to be talking a little bit about class composition, which is distinct from class inheritance. So we have class composition, and then up here we have class inheritance. So, what is the definition of class inheritance? As we briefly discussed before, it's like a parent-child relationship, right? So you could also say it's it has blank. So for example, a or yeah, a parent-child relationship is probably the easiest. So it is a type of blank. So for example, you could have a fruit class, and then you could have like a apple or a pear, not fear, pear, banana, etc. subclasses, right? So your fruit class could maybe have some attributes for like price, color, shape, size, things like that. And then your apple, pear, banana, etc. They're all types of fruits. So that would be a good example of class inheritance. Now, another way that that can be phrased is as a is a relationship. So, for example, an apple is a type of fruit. A car is a type of vehicle, etc. Class composition switches around the paradigm a little bit. And this is not a replacement of inheritance. It is not, it is meant to work in conjunction with, or yeah, with inheritance. So while inheritance says that it is a type of relationship, class composition is about has a relationships. So it's basically about the parts of a whole, if you want to think about it that way. So what class composition is it allows you to essentially, one might say, nest classes within each other. So let's go back to that fruit class, right? What are some things that fruits have? They might have seeds. They might have skin. And like flesh is probably not the right word for it, but we'll stick with that for now. If anyone who knows cooking in more detail knows what the best part of a fruit is, let me know and I will change the name of it. But those are 3 examples of things that fruits have. Now, each of those things is not a type of fruit, but it's an attribute that the fruit has. So what we could do, for example, is we could define like the a seed class, or a seed class then has, we could say fruits have those, and then the seed class has a bunch of attributes. It could be like size, shape of seeds. Then we could say like the skin class would be smoothness and color, and then stuff like etc. So this is a has type of relationship, which is different from a it is a type of relationship. Does that make sense? But before we jump into how to code that. All right. So why don't we actually build out this fruit class? So let's say that we're gonna have a fruit class. So we'll call it class fruit in the same way that we define normal classes. And we'll define our init statement, and we'll just do a self. We can say like type of fruit. And then we say self dot type of fruit equals type of fruit. So that's our first part of that definition. So now what we could do using that is we can make our little subclasses of apples, pears, bananas, etc. But you guys already know how to do that, so we won't get into that right now. What we are going to talk about is this class composition. So let's make a couple of new classes. So let's make a seed class. So we could say define init, and we'll say self. Size and color. And I'll say self.size equals size, self.color is color, and then we'll make a skin class, and we can say, let's see, we have self, and then we're going to have smoothness and also color, and then we can copy these attributes over. Oop, smoothness. Yeah, that should be good. So we now have our three different classes, but we need to find a way to link all of these classes together. So again, recall that from what we talked about, we said that fruits have seeds and skin. So what we could say now is we have, in addition to our overall descriptor of type of fruit, we could say we have another thing called fruit parts. And what we could say here is self dot fruit parts equals fruit parts. Now, why would I want to do that? What is fruit parts? Well, what we could say is we could say seed one, which is some random type of seed, is going to be a new seed, and we'll call it, let's say it has size of 12, and color is going to be brown. And then skin one, this is going to be for like an apple. So we'll say the skin color is we're going to be say that it's smooth and that it is a really nice red apple. So if we want to define a fruit, what we could do is we could say my apple is going to be a new type of fruit. So the type of fruit is going to now be an apple. And this apple has two parts. It has, let's say that it has one seed for some reason, and it has a specific type of skin. So using this, what we've done is we've said my apple is a type of fruit. It has the type of fruit is set as apple, and its fruit parts are two other classes. It's a seed and skin. So let's break this down and let's take a look at how this works in practice. So the first thing that we're going to do is we're going to print out my apple. So let's hit run on that. And we see that that is indeed a fruit object, which is what we expect because we defined it as a fruit object. Now, if I were to check about what data type a type of fruit is, we can print that out and run it. And that just returns a normal string. And we wanted to take a look at what's inside of fruit parts and run that as well. And you now see that fruit parts consists of a seed object and a skin object. So essentially what we've done in our fruit class is we have defined, we can say fruit that now has a type of fruit, which is a string. We now have, then in that we have fruit parts, and that has two other things. That now has a seed, which is your seed class, and your skin, which is your skin class. And then each of those, conjunction, has a has its own attribute. So we have smoothness, and we have, oh, that should be size and color. And here we'll just copy, oop, no. We will copy paste those. And then this one would be smoothness and color. So this is how we've created a class composition, where your fruit class now is composed of not just strings and booleans and integers, but of other of other created classes. So the last thing that we can do is because we have this fruit parts that contains an array with, or a list with one seed object, one skin object, we can get details about the things inside our class composition. So let's say that I wanted to get some details about the color of my fruit skin. So this has, let's see, two objects in it. So we'll go to index 1, and that should be a skin object. And now, since that is a skin object, I should be able to access its color. If we hit run on this now, we see that it's red. So how did we get this to spit out red? Well, again, let's go back through our original class structure. So we started off by going to fruit. All right. From fruit, we went to fruit parts. From fruit parts, we went to skin. From skin, we went to color. So color is not an attribute of the fruit class directly. But because color is an attribute of skin, and skin is composed into the fruit class, we can access the attribute color of the skin of the fruit. It's very much a like fruit has skin, which has a color type of relationship. Now, we could have done this a slightly different way. Well, we could have done, instead of making it fruit parts into a list, as we could have said self.seed is going to be seed, self.skin is going to be skin, and we could replace this like so. So that way, you're directly adding, and here, let's change this to skin. You're directly at inputting the classes themselves into your class, the other classes that are being composed in your class into the class directly. So we get rid of that fruit parts, I'll call it an array or a list, and we just end up with seed and skin being defined directly. So that simplifies things a little bit, because now we can just say fruit dot skin or seed, whichever one, dot whatever attribute we want from it. And if we run this code, we still get the exact same result. So in summary, in summary, class composition is different from class inheritance in that class inheritance allows you to take methods and attributes from one class and put them into another because they're both similar types of objects. Class composition allows you to nest objects or nest class objects within each other in terms of this class is part of a larger one. Any questions on that? All right, so let's walk through one more example before we continue. So, let me comment this out. Okay, here's an example. Let's say that you are making a recipe book. So you're going to define a recipe class. So what things might your recipe class consist of? For simplicity's sake, let's say that you are going to have a list of ingredients and a list of steps. Now, let's also say that, so ingredients are pretty simple. You just have like a type of ingredient and a quantity. So maybe that on its own doesn't need a class. However, steps can be a little bit involved. So maybe we should add a class for steps of your recipe book. So each step could have a time allotted or time it takes for it. You could maybe say action, like what you need to do in that step. And you could say ingredients used, for example. So the recipe class will have each recipe probably has multiple steps. So this is another use case for class composition. So we can define our recipe class. Well, let's define our recipe class. We could say define our init function. We could say self dot ingredients list is ingredients list, and we'll make sure to put that in here. And then we can say self dot list of, or steps list is going to be our list of steps. Steps list. So now we need to define our step class. So we can do something pretty similar. We'll define our init, and we could say time taken, action performed, ingredients used, and we could say something like self dot time taken is time taken, self dot action performed is action performed, self dot ingredients used, ingredients used. And then lastly, when we actually make, let's say, a recipe, what we can say is something like step one is going to be an instance of the step class, and we define all those things in it. Here, let's just do a simple example. Let's say it takes 10 minutes for stir, batter, and then the ingredients used is going to be batter. I don't know what I would be making with this, so we're going to make up very random steps. Let's say the second step takes 35 minutes, and you're going to pour milk into batter, bake at 350 degrees. And so that's going to use milk and your batter. And then step 3 is going to be our last step, which is going to take 5 minutes and put in the freezer. Again, not sure what this would be, and it probably would taste terrible. And that doesn't end up using any ingredients. So we have our 3 steps, but we need to turn those steps into a recipe. So what we could say is recipe 1 is going to be a new recipe that has an ingredients list of milk and batter. And then the steps are going to be a list of step 1, step 2, and step 3. So, we should also probably put a name. That's probably a good thing to do. Self.name is name. And let's call this good recipe. Okay, so based on what we just talked about with class composition, I need to know what action to perform for step 2. How, with forgetting everything we did on line 73 to 75, you only have the information on line 77. How would you get what action is performed in step 2 from recipe, or from recipe 1?
So recipe.step list.
So let's try that. So let's do recipe 1 dot steps list. Let's print that out.
Now I'll give this.
So that's
yeah.
close though, because that gives us the 3 steps. So
Where you put the 1 or 0 in square brackets after it? For step 1, did you say?
Step 2. So that would be index 1. It's confusing thanks to Python being 0 indexed and me typing this like a normal person and using a 1 index. But so we now have our step list. We're going to access the first item in it. The first item in it is a step object. And now for the last part, how do I get the action performed during that step?
Dot action performed.
Perfect. And if we run that, we see that we have the action performed. That should be at ease. So this is a relatively simple example of how you can obtain a attribute of a composed class within a larger class. We can also use these in class methods. So I'm going to write up a quick example of how. Let's say you have these 3 steps. How long is it going to take for this recipe to get done? right? That's usually something that goes with a recipe. So what we can do is we can, well, let's take one step back. So if I gave you a list of 10, 35, and 5, how would you sum that list in Python?
We can use methods. We just do sum parentheses with the listing.
Yep, that's pretty good. So then let's go one step further. Instead of me giving you 10, 35, and 5, like so, I gave you this list of step 1, step 2, and step 3. And my goal, again, is to find the sum of the time taken for each step and sum them all together. How would you calculate that?
Is there a way to iterate through that list? And then
It's a normal list. So how might we iterate through the list?
for step in steps or for step in, what did you call it? I have to go back up a little bit.
Now
Steps list.
all right, so let's say so for step in steps list. Yep.
Time, would you call that time taken?
Mhm.
Plus time taken plus
So I guess we can make a variable that's like total time and set that to 0, I suppose, right?
sure, and plus equal. How would you get to the time taken? Just would you have to put the recipe 1 steps taken, time taken, and would you have to do all that?
Right here, let's actually just do it inside here. So let's say self.total time is 0. Here, so let's do it in the context of the class, which is actually what I meant to do. So remember, steps list is an attribute of the class now. So you correctly said that we need to iterate through that list. So you now have your individual step. How do we get the time taken of an individual step?
Would it be calling that attribute step dot time taken? So
That's pretty much it. So what are we doing in this little for loop down here? What we're saying is we're first initializing a brand new class attribute and saying that total time is 0. Then we know as developers that steps list is a list of steps, a list of step objects. So if I ask you, how do we get the time it takes for one step to get done? We can determine that by doing step dot, or, step is a generic step here. Step dot time taken. Because that's what we defined it as up here. We have step and it has an attribute of time taken. All we're doing in this loop is we are iterating through a list of class objects and just summing them together. So what this is going to do is it's going to say for our example of step 1, 2, and 3, it's going to go first to step 1, which is this step over here, and then it's going to go to its time taken, which is 10. Then it's going to go to step 2, which is this guy over here. And it's going to go to its time taken, which is 35. And it's going to add that on. And it's going to go to step 3 and go through the whole thing for step 3. It's going to find that 5 is the time taken and add that on. And to check that what I'm saying is actually correct, we can now, with a recipe 1, we can print out the total time recipe 1 takes to run, which if we did everything right, should be 10, 35, that's 45, 45 plus is 50. So this should hypothetically take 50 minutes. Interesting, we get an error. All right, so I this time I do know where the error is in the code.
Is it
And this,
because you put it before the class step?
that is close, but not exactly. So this does not have anything to do with class composition. This has to do with me missing one word and one character.
Is it self dot?
Felt that whole time, yeah.
Yep, it's the self dot. Why? Because up here I define self dot total time as 0, and here I'm just referring to total time, which doesn't exist. So it's saying local variable total time referenced before assignment, because I never said what total time was. If we do that self dot total time, I hit run now. There we go. And it does indeed go through all of the steps in that list and take out the time taken and sum them together as we desired into our total time variable. So iterating over lists of class objects is something that you will end up doing pretty frequently when dealing with class composition. Does the overall process that we just walked through make sense?
Yeah, I guess it could run into some errors if you pass in the wrong class into your list, because then you wouldn't have a total or a total time in there. You might have something else. You have to be very cautious of that, huh?
Yes, you definitely do. And that is where number one, for some of these assignments that we do, you don't necessarily need to worry about that. But in general, that is definitely something to be concerned about. And that's where writing good error throwing code can come into things, or making sure that you have good test cases can come in handy. So are there any other questions about class composition versus class inheritance, or how to access lists of classes?
It might be a little like recursion where it makes perfect sense when you're doing it, but I'm just probably gonna need some practice. Or I can do it by myself.
Fair enough.